All right, everyone. Today we are going to take a look back at roots, also known as radicals, and we're going to look at them through a slightly different light. So, the thing that we had consistently talked about is square roots. Okay, we had an entire unit on it, and remember, when you're taking the square root of a number, you're basically finding what number squared gets you the number under the root. So the square root of 9 would be 3, because 3 squared is 9. Now, what we're going to introduce is this concept of what we're going to call nth roots. Okay? And we've got a pretty good definition on here. I'm going to trust that you guys can read it, but basically it means we can put a little teeny tiny number kind of on that little tail area of the root, and it can change what we're eventually going to call as the index of the root. You can kind of see that a little bit further down the page. And what that means is, instead of trying to find maybe what number squared equals a number, we can use almost any exponent we want. So the example here is a really good one. The fifth root of 32 is 2 because 2 to the fifth equals 32. Okay, so basically what this means is, if I'm trying to take the, for example, fourth root of something, maybe the fourth root of, let's say, 81, what I'm actually looking for is what number to the fourth power equals 81, and in this case, it's 3. 3 times 3 times 3 times 3 would get you 81. Okay, so that's kind of what an nth root is. Now, one thing that we haven't explicitly talked about, but we should, is something called the principal root. Okay, so we mentioned this a lot in the square root chapter, right? Like, technically, if you're looking for the square root of 4, you can make an argument that that answer is 2. You could also make an argument that it's negative 2, because negative 2 squared would also get you 4. However, when it has two roots like that, the positive root is what we call the principal root. Okay? And if you just see just a plain radical sign already there, it indicates the principal root. Okay, so if you see the square root of 4, you would just put that. There's also a mention here of some imaginary numbers. So if you're taking a root of a negative number, we can use this imaginary number symbol. We're not going to get into that too much right now, but it's good to know that you can actually take like the square root of negative 4. Okay, it is possible, and you would actually write that as 2i, because the square root of positive 4 is 2, but because it's negative, we're going to use that imaginary number indicator. Okay, so next definition is radicand. Okay, so radicand is the number under the radical sign. So in this expression, this says 2 times the fourth root of 7. 7 is the radicand. And just as we talked about above, index, that tells you what degree of the root. So if you see a fourth root, the index is 4. If you see a cube root, the index is 3. If you see a square root, it's assumed that there's a little teeny tiny 2 there, but we do not write it. Okay, it's assumed there's a little teeny tiny 2 there, but we do not write it. It's always considered a square root if you don't see an index. Okay? Now, a couple things. This is kind of telling you the difference between an odd root and an even root. Okay, so if your index is odd, there's only ever going to be one root. Okay, and the simple reason is kind of this. I can kind of show you two different examples, right? The cube root of 8 and the cube root of negative 8. The difference when we have a odd root is that you actually can get negative numbers, and you can do the root of negative numbers. So here, 2 times 2 times 2 is the only thing that gets me 8. So 2 cubed is the only thing that gets me 8. Here, negative 2 cubed is the only thing that gets me negative 8. There's only one possible answer for both of those. So odd roots, if it's positive, it'll be positive. If it's negative, it'll be negative. Now, if it's even, that means there are actually really two roots, right? If we're taking the root of a positive number. So basically what we're saying here is, if we took the fourth root of 16, technically both 2 and negative 2 would work there, right? If we multiply 4 2's, we get 16. If we multiply 4 negative 2's, we also get 16. But remember, The positive root is the one that we call the principal root. So if you just see that symbol, you're supposed to assume it's the positive, okay? Now, if that number under there is negative, there are no real roots then, okay? So if we're taking the fourth root, for example, negative 16, there are no real roots there, okay? And we're going to focus on real roots for right now, okay? Last thing that we kind of need to know, if you are taking any kind of root of 0, it's 0, okay? These are all the important terms that we need to know. Index, again, that's that little number. Radicand is the number under the root. And then the sign itself is just called the radical sign. Okay? That should really be about it for kind of our basic properties. The last thing, this is kind of a big one, and it's this idea that squaring and square roots canceled out. We've actually talked about that before, right? Like if you take the square root of 2 squared, it's 2. If you take the square root of 5 squared, it's 5. Okay. Now here's a little bit of a difference, though, if we're talking cube roots versus non-cube roots. Odd roots versus even roots. Okay. If it's an odd root, you can just use the number itself. Okay, and it doesn't matter if we're talking positive or negative because we can get negative answers. Okay, so a couple quick examples there. The cube root of 2 cubed, and I'm putting parentheses in here to make a point, would be 2. The cube root of negative 2 cubed would actually be negative 2, because negative 2 to the third is negative 8, and we can do a cube root of a negative there. That's totally okay. Now, if we get into the even realm, okay, so if we're doing fourth roots, the fourth root of 2 to the fourth would be 2. And here's where it gets a little bit odd, right? But we've seen this before. The fourth root of negative 2 to the fourth, that would also be positive 2. Because if we actually do the order of operations there, negative 2 to the fourth is positive 16. And when we're taking the fourth root of positive 16, we're supposed to give the principal root, which is positive 2. Okay, that's what this absolute value definition is all about. You will not use the actual absolute value symbols when you can just simply write the positive number. However, here's where this is really important for us in terms of variables. In terms of variables, what this means is this. We said the square root of x squared is the absolute value of x because it should be a positive answer because squaring it and then square rooting will always lead us to a positive principal root. Okay? If we do this with a cube root, though, if we're taking the cube root of x cubed, this is no problem then. Then this is just regular x because that answer could be positive or negative. Okay? If we go to the fourth root of x to the fourth, now we have to go back to absolute value of x. They still cancel each other out, but again, we want a positive quantity there. Okay? So if you are canceling out with an even root and there's a variable involved, you're going to have to use that absolute value. If it's odd, then you don't need to worry about it. Okay, we have a couple examples here. You're supposed to try to find the cube root of each of those, so you're imagining there's a cube root symbol around each of those. Try doing these without a calculator and see what you come up with. So just take a minute, try all 3 of these problems. Okay, and what you should have gotten here is 0.4. Because if you do 0.4 times 0.4 times 0.4, you're going to get 0.064. 4 times 4 times 4 gets you 64, but if we got that decimal point in there, now we've got 3 decimal places. You can do the cube root of negative 5. Sorry, that cube looks terrible. It is just negative 5. When you're doing the cube root of a fraction, we talked about this back in the square roots chapter, but you are allowed to separately take the cube root of each of those numbers, okay, and you should get a 1 up here, because 1 times 1 times 1, or 1 cubed gets me 1, and 2 cubed gets me 8, so that should get me 1/2. Okay, hopefully all of those were good for you guys. Now we want the real fourth roots. Here's the key. There's the word real is in here, okay? So try each of these and see what you come up with. Okay, hopefully for 81, You hopefully got 3 because 3 to the 4th is 81. Again, we're trying to take the 4th root. If we try to take the 4th root of this, we're going to get 0.2. And if we try to take the 4th root of this, there is no real root. Okay, so there is no real root there. Because you can't take an even root of a negative and get a real number. All right? Now just try each of these individually. Again, we are looking for each real number root. So if it's not going to be a real answer, just write no real root. Okay, cube root of negative 27. We can do cube roots of negatives. That would get us negative 3, because if we take negative 3 cubed, we get negative 27. The 4th root of negative 81, that one has no real root. Okay, because it's an even index, okay, so we will not be able to find a number to the 4th power that gets us a negative. Here, order of operations matter. This is positive 7. If we were to do the squaring first, it gets us positive 49. Square root of positive 49 is positive 7. But down here, square root of negative 49, this is no real root here. No real root here. Again, we could probably use imaginary numbers for some of those, but we're going to stick to the real roots for right now. So now this is where it gets a little bit tricky. So I'm going to show you guys this first one, and I'll see if you guys can kind of figure it out from here. Actually, you know what? I am going to show you C. Okay, because I think C is kind of a little bit different. A should be a review from the square root chapter, hopefully. So if it's C, you are looking for, in each of these cases, how many 4th exponents can go into each, okay? So just like we did when we broke things up into like x squareds and y squareds, this time we're going to break them up into x to the 4ths and y to the 4ths, as many as we can. And what we're going to find here is that then when we take the 4th root of each of those, they turn into just a regular x or just a regular y. So that turns into an x, an x, an x. That turns into a y, a y, a y, a y. And when we combine, we get x cubed y to the 4th. Now, the last thing you need to decide is whether or not you're going to use absolute values. It's an even root, so there's a chance we need to use absolute values. I'm only going to put them around x cubed, though, because that's the only part that has a shot of being negative. Y to the 4th will be positive. X cubed, we're going to have to kind of force it to be positive. So we'll put absolute values around it. Now, there was perhaps an easier way you could have done this. Remember, if you're just trying to see how many 4s go into a particular number, you could have just divided by 4, right? So 12 divided by 4 is 3. That means there are exactly 3x to the 4ths. That'll go in for those x's. Same thing with the y's. And sure enough, we get x cubed y to the 4th. Let me quickly make up a different example and show you what happens if we've got some stuff left over. Okay, so if we were trying to do the 4th root, we'll do that again, of x to the 14th and y to the, let's go with 17th. You can just break it up into x to the 4ths and y to the 4ths, okay? But if we use the kind of divided by 4 trick, if we do 14 divided by 4, what you kind of want to think of this of is with remainders. I know we don't usually write this with remainders, but you kind of want to know how many x's are left over. So this would be 3 with a remainder of 2, or 3, if you want to, 3 and 2/4. I'm actually leaving it as 2/4 and not 1/2 because that tells me, that numerator tells me how many x's or how many y's I have left over. Okay, same thing with the, I don't need the y there, 17 over 4, that's going to be a 4 with a remainder of 1, or it's going to be 4 and 1/4. Okay, so my final answer here would be x cubed, that's coming from here, with 2 x's left under the root, right, because 4, 8, 12, and then 2 left over. And then here, I would get a y to the 4th on the outside with just 1 y left over. That's coming from 4 with the remainder of 1. And I still need the absolute values here. Okay, so it works very much the same way that it does in the square root chapter. And again, you could write this out as many x to the fourths as you can, and what you'd find is you'd have 2 x's and 1 y left underneath the root. Why don't you guys go up and try A and B, and then give a little pause and then come back. Okay, remember to use absolute values only if you need to. So root 81 x to the fourth, the square root of 81 is 9. Square root of x to the fourth is just regular x squared. And I need to look to see if I need absolute values because it wasn't even index. However, because x squared is guaranteed to be positive, I actually don't need to use any. So that's my final answer. Cube root of a to the 12th, b to the 15th, there will be 3 can go into 12 4 times. Okay, so that means I've got an a to the 4th, and there'll be none left over under my root. Make a better a, there we go. And 5 times will 3 go into 15, okay? So that'll be b to the 5th, and again, none left over, so I don't need to write cube root of anything. That doesn't need to be there because there were none left over, okay? And I don't need to look at all for absolute values here because it was an odd index, okay?